In this video, I'm going to explain the details of Activity 6, which is the activity that you're completing this week. When I do this activity in class, or in an actual classroom, what I do is I have the students in class participate in a recall experiment, and each student gets a recall score. Then I put the recall scores on the board, and we answer these questions based on the results of the experiment. But we can't do a recall experiment very easily this semester because the class is online. So what I'm going to do is I'm going to describe what I would have done with you if we had done the memory experiment in class. I'll describe the procedure we would have gone through, and then I'll give you a made-up set of recall scores that you'll use to answer these questions, and you'll pretend that we actually did the experiment and that these recall scores actually are your recall scores. So first of all, I need to show you the procedure we would have gone through. So let me pull this up. So imagine that we're in class at 9 a.m. and there are, I didn't have to choose 9 a.m., but I'm just using that as the number I decided to use. And imagine that there's 32 students in our class and that I randomly assign the students to two groups of 16. And what I do is I have group one watch a slideshow of 12 two-digit numbers presented one at a time on the projector. And group one is shown these numbers in ascending order, which means the slideshow starts at the lowest number and then it advances upward, and each number gets higher and higher. And then the last number that's presented is the highest number. So here's an example of an ascending list. List of numbers in ascending order. And like I said, I'm presenting these numbers one at a time on the projector until the slideshow finishes. And the slideshow is presented at a rate of 2 seconds per slide. And every slide has one number, which is the presented number, in the center of the screen. And that number is always in black Times New Roman 80-point font. And the background is always white. So it's always one number in the middle of the screen with a white background in a PowerPoint slideshow. And after this list of 12 numbers is finished presenting, the screen turns blank, and group one is given 5 minutes to write down the numbers that they remember seeing, and they're told that they can write them down in the order that they come to mind. So each participant in group one has a sheet of binder paper or just blank paper in front of them, and they look at the paper, or they look down, and they just write down the numbers that they remember seeing, and just in the orders that they come to mind. And each person does this individually. And after the 5 minutes is up, I tell everyone, please stop trying to remember items and to turn in your recall sheets to me. And then what happens is, well, each person in group one is told to, each person in group two is told to close their eyes while group one is watching the slideshow. So group two doesn't see anything while it's group one's turn. And then after group one finishes the recall task, it's group two's turn. So group two has the exact same experience as group one, except the numbers are shown in a rearranged random order. So once it's group two's turn, I show the same numbers one at a time in a slideshow to group two, but the numbers are in a random shuffled order. So the numbers might go 34, 11, 24, 77, 42, and so on. So group two is getting the same exact experience, except they're watching a shuffled order presentation. And after the last slide is shown, it turns blank, and just like group one, group two is given 5 minutes to write down the numbers that they remember. So each participant looks at their blank sheet and writes down whatever they remember seeing in whatever order it comes to mind. And after 5 minutes, everyone in group two turns in their sheet, their recall sheet. And all 32 people, all 32 participants total, get an individual recall score. So here we're imagining that these are the recall scores of the 16 people in the ascending group and the recall scores of these 16 people in the random group. And every person, every participant gets a recall score between 0 and 12 because the recall score is just the number of items that are correctly remembered. So if a person doesn't remember, if a person isn't able to remember any of the 12 numbers that were presented, the score is 0. And if a person remembers all 12 perfectly, it's a perfect 12. So it's each recall score is just the number of presented items that actually ends up on the person's recall sheet that they actually end up writing down. So what I want you to do is enter this data into a statistical, well, there's a website that can calculate the statistics that you need, and I'm going to have you use that website and then use the output of the website to reach a conclusion. So let me show you the website you'll be using here. So go to two-sample T-Test calculator. And you'll need, let's see here. Let's see which one is better. Yeah, so this is the one I actually wanted. So a two-sample T-test is what a researcher would use if a researcher was doing an experiment with two separate groups of people, like ascending and random, and the researcher wanted to test if there's a significant difference between the mean of group 1 and the mean of group 2. So if you have a two-group experiment and you're testing whether the difference between the mean of group 1 and the mean of group 2 is a significant difference, that's a two-sample t-test. And that's a situation that we're in because we're comparing the means of two groups, ascending and random. And we want to know if the difference between the mean of ascending and the mean of random is a significant difference. So we're going to do our two-sample t-test. And let's see. So yeah, here it's called an unpaired t-test, but that's the two-sample t-test. And what you need to do is enter the 16 recall scores for ascending that I provided in group 1, and it'll go down to row 16. After you're done, enter the 16 scores for the random group in the group 2 column, and that'll go to row 16. And then after you're done, click Calculate Now, and you'll get the results you need. So just so I can show you how to use this, let's pretend that that the ascending group has 5 people and the random group also has 5, and I'll just make up some numbers. So let's say that the scores were, well, let me make it more realistic. Let's say that these were the 5 scores for ascending, and let's say that these were the 5 scores for random. Then we click Calculate Now. And make sure, don't use the 10 numbers I have there. Make sure you use the 16 numbers I provided, because I just made up those numbers on the spot just to show you how to use the calculator. So this is what you'll need for the activity. So let me go down here. Right here, we have the mean recall score of group 1 and group 2, the mean of ascending, and the mean of random. Well, mean is average, so it's the average of group 1 and the average of group 2, ascending and random. You don't need the standard deviations for this activity or the sample sizes, just the two means, which in my case are 7 and 3.2, because these two means tell you which group has the higher average. And in addition to the means, you need something called the p-value up here. And this tells you if the difference between the means is a significant difference. So here, we can see that the two means are 7 and 3.2, and we can see that they're roughly 4 apart. But we want to know if that 4-point difference is big enough to be statistically significant. And that's what the p-value will tell us. So let me show you how to use this p-value. So if you've taken a stats class, you might have learned about 0.05 cutoff. So if P is 0.05 or less, it's a significant difference. And some examples might be 0.02, 0.03, 0.045, or even 0.05 itself would be significant. These would all be considered significant because they're all 0.05 or something under 0.05. So 0.05 counts as significant because it's right at the cutoff, and anything under is also significant. But if it's above 0.05, that's not a significant difference. And I think the reason why this gets a little bit confusing for some people is because you actually, if you want a significant difference, you actually want a low p-value, not a high p-value, because the p-value has to be low enough to be significant. It has to reach the cutoff or go under the cutoff. So if p is above 0.05, that's not significant. So like I said, it's kind of the opposite of what your intuition would say, but this is how it works. So an example of a p-value that wouldn't be significant might be, well, 0.051. That's just barely too high to be significant. It's above the cutoff. 0.06, 0.08 wouldn't be significant, or something higher like 0.17. Anything above 0.05 is not significant. So what you'll need to do is look at your p-value and decide if our results are significant based on what I just told you. So if p is 0.05 or less, then the difference between, if p is 0.05 or less, then the difference between the groups is a significant difference in performance, and one group actually did do significantly better than the other. But if it's not significant, then the difference is not significant, meaning even if one group has a higher mean than the other, it's not enough to be significant. Okay. So here what you need to do, so let me go through these questions one at a time and explain what you let me kind of guide your thinking here. So it says, which group performed better at the recall task? You'll need to look at the two means in your output and just look at which mean is higher, and that'll tell you which group did better. And your answer will either be ascending or random, one or the other, just depending on which group has the higher mean average score. This says, is the difference between the mean of ascending and the mean of random significant? You have to use the p-value, which will be in your output. Here I want you to, so if the difference is statistically significant, I want you to explain what that means in everyday language. So you might want to go back to video 1, the very first video I showed you, which explains what it means to have a significant result. And if it's not statistically significant, I want you to explain what that means in everyday language. So, so sort of interpret the results for someone who isn't really very, someone who isn't very familiar with a statistic or the language people use in statistics. Just like maybe interpret it for a friend who maybe took stats 10 years ago or something like that, or maybe for a friend who's never taken stats. Here, so do our results match the results of Houston 1976? So here what I want you to do is go on PsycInfo and look up the original article. Well, look up the study that actually tested ascending and random number lists, because This experiment was actually done by someone called Houston, and the results were published in an article. And I want you to see if our imaginary results match the results that they found when they compared ascending and random recall. So when you go to PsycInfo, the keywords you need to use are, well, recall, ascending, and random numbers. That should pull up the article. And if that doesn't work, put in the name Houston also as an author name. And then when you see the article, let's see. I think I can show you what the title is. Maybe it'll come up in a Google search. Um, Encoding and retrieval in ascending and random lists of numbers. That's the one that you're looking for right here. And when you open up the article, you need to go to the results section, and there'll be a table that tells you the mean recall score for ascending and the mean recall score for random. You need to look at those two group means. And when you look at the table, you'll also notice something that says, well, let's see, you'll see ascending input and random input, which are what's being compared. But then you'll also see something that says ascending output and random output. So let me show you what it might look like. So this is the ascending presentation and the random presentation. They asked half of their participants to actually recall the numbers in ascending order. So this group right here, ascending output, actually had to write the numbers that they remembered in ascending order from lowest to highest, whereas the random output group was allowed to just write them in any order they came to mind. So this part right here actually doesn't apply to our experiment because we're not doing ascending output as part of our experiment. We're just doing the random output. So what you need to focus on is just random output. And you need to compare the mean of ascending right here with the mean of random out here. Because this part is what's similar to our experiment. It's what we're actually testing in our activity. And what I want you to be focusing on here is whether the group that performed better in our experiment is the same group that performed better in their experiment. So if ascending did better in our experiment, check whether ascending did better than random in their experiment as well. And also I want you to focus on the size of the difference. So look at whether the size of the difference between ascending and random performance is the same as the difference in performance in their experiment. So if let's say ascending, well, let's say in our experiment that ascending has a mean of 9 and random has a mean of 7, that's a 2-point difference. And let's imagine that in their experiment, ascending has a mean of 9 and random has a mean of 4. That would be a 5-point difference. If that's the case, I would want you to mention in your answer that that even though ascending did better in both experiments, our difference in performance was smaller and their difference was bigger. So that's something to also focus on. So yeah, focus on whether the group that did better in our experiment also did better in their experiment, and focus on whether the size of the difference between the group means is the same or different. So that's how I want you to answer this question right here, question number 4. And what extraneous variables were controlled in our experiment? So an extraneous variable is a variable that isn't being studied, but could affect the results or affect the data. So in our experiment, an extraneous variable is, well, anything other than the presentation order that could affect people's recall scores, because in our experiment, we're testing the effect of presentation order. That's what we care about. And anything else that could affect recall performance is extraneous. It's outside of the focus of our study. So extraneous variables in our experiment would be things like the temperature of the room, the time of day, the amount of time people are given to complete the task, if they're rushed or not rushed, the speed at which the items are presented, because it's more difficult to memorize a fast presentation, the amount of sleep the participants have had the night before, maybe how hungry they are. These are all extraneous variables that could affect recall. So what an extraneous variable is controlled if it's held constant and it's the same number for everyone. It never changes. So if I give everyone 2 minutes to recall, if I give everyone 5 minutes to recall the items, then you would say that the recall time or the time to complete the task is controlled because it's equal for everyone. Or if I tell everyone that you have to eat a 100-calorie meal for breakfast on the day of my experiment, then calorie intake is controlled because I've ensured that it's the same for everyone. Everyone has 100 calories. Or if, let's see, let me just think of just one more example. Well, if I test everyone at the same time of day, then time of day is controlled because it's the same for everyone. So what I want you to do is just look back in my description of the experiment, which the procedure which I gave to you, and we'll look at this slide right here and the other slide also, which are shown earlier in the video, and look for things that are controlled. I mean, look for extraneous variables that are controlled in our procedure. So each time you see something that could affect recall, and it's something that I've held constant for everyone, that's something that you could talk about in your answer because that would be an extraneous variable that's been controlled in our procedure. So yeah, just describe what extraneous variables were controlled. And question 6 says, if someone said to us, what if the ascending group just had better memorizers than the random group? Or if someone came up to us after our experiment and said, well, I know that the ascending group did better, but what if the presentation order actually didn't make any difference? What if the ascending group was just full of people who were just naturally good at recall? What would we say to that person to make the person confident that the presentation order actually did make a difference? What would we say to them to help defend our conclusion and help them actually help them become confident that the presentation order actually does make a difference, and that our data is actually supporting our hypothesis. So I'm just giving you some practice at defending a criticism of an experiment. So you might just giving you practice for in a situation in which someone offers a critique and just responding to the critique to defend your result. So here, so based on what you understand about significance, statistical significance, just answer this multiple choice question. The answer is either A or B. And base your answer on the result of our imaginary experiment from the output of the t-test. And here, I have some questions that you could just answer without any statistical testing or without the website, because these questions are just based on your understanding of the material we've covered. So, well, first I want you to explain the thinking behind your choice in part 7, and then what I want you to do is explain why our experiment of ascending and random isn't a non-equivalent groups design. So just give 1 or 2 sentences explaining why it's not this type of study. And also mention in our experiment, what's the name of the independent variable? What are the names of the levels of the independent variable? And what is the name of the dependent variable? So if you need to, just go back and review the latest topic and ask me questions if you're a little bit stuck on this topic. And question 13, just say in 1 or 2 sentences why it's a weakness of our study that we have a non-random convenient sample. So in our imaginary experiment, the participants are a Psych 120 class. So we don't have any participants outside of Psych 120, which means our participants are just a convenient sample of almost all psychology senior students at SJSU. And explain why this is a drawback of the study. And in 1 or 2 sentences, and answer this multiple choice question 14. And then let me quickly explain 15 and 16. So when I did this experiment last semester, what I did was I forgot to tell group 1 to close their eyes. So, well, I did the ascending order first to group 1, and then afterward I did the random order for group 2. So, but when group 1 was watching their ascending presentation, I didn't tell group 2 to close their eyes. So what actually happened was group 2 watched the numbers in ascending order, and then later on, when it actually came to their turn, they watched the same orders in random order, and then they did the recall task. So they saw the slideshow presented twice when they actually were supposed to see it only once. They saw both presentations. Well, and I think that some people might have turned their eyes because they knew that they weren't supposed to be watching the other group's presentation. But it's probably true that at least some people did watch both presentations when they shouldn't have. So remember that group 1 watched the ascending order only because they came first and then they were tested. But group 2 watched the ascending presentation order. Then what they did is when it came to their turn, they watched the random order, their actual presentation, and then they did the recall test. So group 1 ascending watched their presentation only. Group 2 random watched both presentations. And what I want you to do is describe what the confounding variable was in this experiment. So I haven't talked about confounding variables yet, but a confounding variable is an extraneous variable that's not controlled, basically. It's basically an unwanted difference between group 1 and group 2. So in that experiment that I did last semester, the two groups were treated differently in some unwanted way, in some way that was basically just an accident. And I want you to describe what that unwanted difference was here. And just 1 or 2 sentences. And then describe, based on what I told you, tell me if you think that this confounding variable gave an unfair advantage to the ascending group, an unfair advantage to the random group, or if it helped both groups. And remember, in last semester, ascending did their recall task first, random did theirs second. And if you have any questions about this, just let me know. Otherwise, just upload a numbered, you don't have to, so open a Word document or PDF and just create a numbered list of answers from 1 to 16 and upload that as your submission. And you don't have to copy the actual questions. All I need is just a numbered list of answers. And there's no, like I said here at the beginning, there's no formatting or length requirement for any question because I'm just looking for effort, understanding, and content. And yeah, if you have any questions about this, just let me know.